Hi, folks. In this next lesson, we're going to learn how to solve multi-step equations. Last time we solved problems that only had one mathematical operation in them. This time, there's going to be two or three or more mathematical operations that we need to deal with. And the general procedure here is that we're going to need to simplify each side of the equation first using PEMDAS order, which is hopefully something you're familiar with from middle school. You do parentheses first, then exponents, then multiplication and division, and then addition and subtraction. But then you're going to go through kind of reverse PEMDAS order to isolate the variable, to get that variable all by itself on one side of the equation. So let's look at an example and see what we do here. Solve this equation and check our solution. So notice there isn't just one number attached to x here, there's two numbers. This 2.5 is multiplying the x, and then this 13 is being subtracted from that multiplication problem. Now, if I can simplify one side of the equation or the other, I should do that as my first step. The left side is already fully simplified. Because I don't know what x is, there's no further multiplication or subtraction or addition, division that I can do here because there are no like terms to add together. So then what I'm going to do is I'm going to focus on getting x by itself. And I'm going to be doing this in reverse PEMDAS order. I'm going to start with addition, subtraction, and get rid of those numbers first. So here I'm looking at that minus 13, and because that's being subtracted away, I want to get rid of that 13 first by adding 13 to both sides of the equation. And remember, the equation kind of separation line is that equal sign. So I want to add 13 on either side of the equal sign. After I do that, I'm left with 2.5x equals 15. 2 plus 3 is 15, and I just have the 2.5x on the left side. Now I want to focus on getting rid of the 2.5. I've taken care of addition, subtraction, and I want to take care of any multiplication, division that I have attached to that x variable. That 2.5 is attached by multiplication, so I want to do the opposite of multiplication. I want to do division. And if I do this division, 2.5 divided by 2.5 is just 1, so I have 1x, which we can simplify as just the letter x. And then 15 divided by 2.5 is 6. So I get that x equals 6 as the solution to the equation. As always, I should check my solution by taking it and plugging it back in where I see the letter x. I put the number 6. And I want to plug this expression in on my calculator and make sure that it does equal 2. Well, 2.5 times 6 is 15. So 15 minus 13 is in fact 2. So my solution is true. The answer checks out. Let's do another example. Negative 12 equals 9x minus 6x plus 15. In this example, if you look at step 1, I'm supposed to simplify each side of the equation if I can. And this time there is some simplifying I can do. 9x and 6x are like terms, so I can carry out that subtraction problem. 9x minus 6x is 3x. I still have the plus 15. I need to carry that down. And that all equals negative 12. This is now as simplified as it can be. And I'm going to focus on going in reverse PEMDAS order to get x all by itself on one side of the equation. Take care of addition and subtraction first. So I'm going to subtract the 15 that's being added on to x. Remember, my focus is that x, getting x all by itself. And when I subtract 15 from both sides, I get negative 27 on the left. And those two the subtraction leaves me with adding 0 on the right-hand side. So I'm just left with 3x on the right-hand side. And now to get x all by itself, x is being multiplied by the 3. So I want to divide by 3. Do the opposite of what I see there. 3 divided by 3 is 1. So I'm just left with 1x on the right-hand side. And negative 27 divided by 3 is negative 9. So x equals negative 9. Let's check our solution as requested. Negative 12 equals 3 times 9. I'm sorry, negative 9 plus 15. And if I plug this into my calculator, I see that negative 27 plus 15 is in fact negative 12. So my answer checks out. What happens if there's a more complicated expression on one side of the equation? So here we have 2 times the quantity 1 minus x plus 3 equals negative 8. There are a couple of different ways to approach this problem. Based off of the procedure that I've given you here, I suggested simplifying what you can. So I'm going to use the distributive property. I'm going to take that 2 and multiply it times each component that I see each inside the parentheses. So 2 times 1 is 2. 2 times negative x is negative 2x. I still have the plus 3, and that equals negative 8. So I've used the distributive property on that expression, that part of the expression. Now that I have this slightly simplified equation, there's a further simplification I can do because I have like terms with the 2 and the 3. Those can be combined together. 2 plus 3 is 5. And then I still have to subtract the 2x. The right side of the equation is still negative 8. Nothing has changed to that. I haven't added or subtracted or multiplied or divided anything from both sides of the equation. I've only simplified what's written on the left-hand side. Now that the left side of the equation is as simple as possible, now I go through reverse PEMDAS order to try to get x all by itself, to isolate x. So I'm going to subtract 5 from both sides, because that's the thing that's being kind of added on to the x. And the 5 is positive, so I want to subtract it away. When I do that subtraction, I'm left with 0 being added on, but I still have the negative 2x left. And on the right side, negative 8 minus 5 is negative 13. And now I'm going to get x by itself by dividing both sides, not just by 2, but by negative 2. By negative 2. I need to get rid of the negative sign as well as the 2, and negative 2 is what's multiplying the x. After I carry out that operation, I get that x equals positive 6.5 as my answer. But I should check the solution by plugging in 2 times the quantity 1 minus 6.5 plus 3 equals negative 8. And if I plug that into my calculator, I do get that 2 times negative 5.5 plus 3 is negative 11 plus 3, and that does equal negative 8. So that checks out, and I know that my answer is correct. I do recommend students make fewer mistakes when they use this process, but there is another approach that you can take, which is just doing reverse PEMDAS order. Remember, parentheses, when you're talking about PEMDAS order, the P stands for parentheses. So when you go in forward parentheses order, you do that operation first. But in reverse PEMDAS order, you do the parentheses last. So what this looks like, if we just rewrite the equation down here. Here, if I'm doing reverse PEMDAS order to try to get x all by itself, I'm going to subtract 3 from both sides of the equation because I'm taking care of addition and subtraction first. I'm left with 2 times 1 minus x equals negative 11. And now I'm focusing on multiplication and division. Well, that 2 is multiplying an expression that has x in it. So I want to get rid of that 2. That 2 is multiplying the expression with x, so I want to divide it away. And this gives me, remember 2 divided by 2 is 1. So multiplying anything times 1 doesn't do anything to it. I'm left with 1 minus x equals negative 5.5. I need to subtract 1 from both sides of the equation because now I have an expression. Now that the parentheses are gone, I kind of start over again about doing reverse PEMDAS order. I'm back on addition subtraction. I need to subtract the 1 away, subtract 1 from both sides of the equation. 1 minus 1 is 0, so I'm left with negative x equals negative 6.5. And then I'm left with negative x. Remember, negative x is not the same as x. X is not all by itself until you get rid of that negative side. I'm going to multiply both sides by negative 1, multiply by negative 1 to negate that negative sign, and we have x equals positive 6.5. We don't need to check the answer again because we already checked it up here and we know that 6.5 is the correct answer. But there is a different approach to solving this equation, and you'll find this very often in math, that there's more than one way to approach the solution. Sometimes there is a faster way, but it doesn't mean that it's the only right way to solve the problem. Let's look at a modeling real life problem. Here we have a chart of how many miles we've biked on different days of the week, and we want to have an average number of miles biked in a day. We want the average to be 5. But if you look, I took Wednesday off. So we want to know, hey, how many miles do I have to bike on Friday so that my average is 5? Remember, calculating an average, calculating a mean is one of those equations I said in the last lesson that you do need to know. Average you calculate by summing all the values that you have and then dividing by the number of values that you added together. So I want my average or my mean to be my Monday plus my Tuesday, plus my Wednesday, plus my Thursday, plus my Friday, all divided by 5, because Monday, Tuesday, Wednesday, Thursday, Friday, that's 5 days. I want to substitute the numbers that I know. So I know I want the average to be 5, the mean, and I'm going to plug in 3.5 for Monday, 5.5 for Tuesday, 0 for Wednesday, 5 for Thursday, and I don't know my Friday, so I'm going to use the letter X. And then I'll divide that whole thing by 5. So as we try to solve for X here, first step is let's simplify what we have. There's a big addition problem in the numerator, and so I'm going to add 3.5 plus 5.5 plus 5, those like terms, and the 0, although the 0 does nothing to it. And I end up with 14 plus x in the numerator divided by 5. Now, to get x all by itself, I want to go in reverse PEMDAS order. There's no addition subtraction in this problem besides what's in the parentheses, and we're going to handle the parentheses last. So I'm going to focus on multiplication division. I need to multiply both sides of the equation times 5. On the left side, 5 times 5 is 25. On the right side, I'm multiplying by 5, which cancels out the division by 5. Remember, a fraction is just division. So we're left with 14 plus x in the numerator. And now I deal with what used to be inside parentheses here. Now I can handle the addition problem. I'm going to subtract 14 from both sides of the equation, and I am left with 11 miles for my Friday bike ride. And I should write units there, miles. Now, it's always important to check your answer to see if it makes sense. And looking at this, since we didn't bike at all on Wednesday, in order to kind of keep the average up, we need to go more than twice as far because we also kind of didn't bike as far as we should have on Monday either. So we have a lot of ground to make up. So it does make sense that I have to do more than double the average to get the average, the mean, up to 5. Let's do another real world example. One person buys a used car in Indiana and pays $10,195, including 7% sales tax and $425 in fees. Another person buys a car in Pennsylvania, pays $9,995, including 6% sales tax and $420 in fees. Compare the list prices of the cars. That's the list price is without taxes, without fees. So I need to know, so the list price plus taxes plus fees equals the total price. Okay, so that's kind of the general word equation that kind of captures what we're doing this. We've got to do this twice. We've got to do it once for Indiana and once for Pennsylvania. So let's do this for Indiana first. I don't know my list price. I'm going to call this X. It's always a good idea to label what your variables are. So my list price for Indiana is going to be X. I don't know my list price, but the taxes are calculated by doing multiplying that list price that we don't know, that X value, times 0.07. Why is it 0.07? Because this 7% sales tax, 7% is the same thing as 7 out of 100, which is 0.07. So that's how the taxes are calculated. And then the fees are $425. And all of that added together gives you the total price, that $10,195. Now, how do we simplify this so that we can solve for X? Well, X plus 0.07X, this can be simplified as 0.07X. Those are both like terms. Those can be added together so that we get 1.07X. Remember, there's an invisible 1 here. 1x plus 0.07x is 1.07x. And now this is a straightforward equation where we just need to subtract 425 from both sides of the equation. And we get 1.07x equals 9,770. And if we divide both sides by 1.07, then we get X equals $9,130.84 was the list price in Indiana. I recommend that you pause the video and try to do the similar calculation for the Pennsylvania car. And then you can resume the video and check your answer and see if it matches mine. The list price for Pennsylvania, let's call that Y, just so that we don't get it confused with Indiana. So my Pennsylvania calculation here, I'm going to have Y plus Y times my sales tax rate is 0.06 this time, plus my fees are $420 equals $9,995. Simplifying, adding these two like terms together, I'm going to have 1.06 times y plus 420 equals 9,995. I'm going to subtract 420 from both sides of the equation, and that gives me 9,575. Now I divide both sides by 1.06, and my y value equals $9,033.02. So Pennsylvania has the cheaper list price on the car. So we have compared those list prices. If you wanted to say how much cheaper it is, it's $97.82 cheaper. So that shows you how you can use this multi-step solving equations process in a real world example. I hope this helped.